This is the second problem on harmonic motion. For this problem, we have a block of mass m, and this block is on a frictionless table. This is important, frictionless surface. This block is attached to a spring constant K, and then an arrow is fired into this block, and this arrow has mass m, and it is fired at velocity vm, magnitude of velocity is vm, and it was done at angle theta with horizontal. So what will happen? The arrow will hit the block. We assume that this will happen instantaneously, the way that the spring will not be compressed during this collision. And then this block with this arrow will be moving back and forth, and what we need to find the position of the block at any time moment. So how can we do that? Well, it's a problem on harmonic motion, but we need to know initial conditions. And we understand that when this arrow hits the block, that's the reason why this block will be moving, and it will be collision. So first of all, my first task is to find the velocity of this combined system, arrow and the block, at time moment 0. To do that, I will use conservation of linear momentum, because external force in x direction is 0. Linear momentum in x direction is conserved. Px before is equal to px after. My choice of x is to the right, which gives me the momentum of this arrow as minus m vm cosine theta. Projection of velocity is negative, momentum is negative with my choice of coordinate system. And momentum of this block before the collision is 0, it is at rest. What is p sub x after? After they move together, it will be m plus capital M, mass of the block, and they will be moving with velocity v sub x that we are looking for. What will be v sub x? V sub x will be equal to minus m divided by m plus m. This is this guy. And then vm cosine theta. Okay, now we know our initial conditions. What are initial conditions for this problem? X at time moment 0 is equal to 0. The block is at position x0 at time moment 0, and velocity vx at time moment 0 is equal to minus m over m plus m, and then vm cosine theta. What's next? Now we need the law. We will write second law in projection in x. Net force in x direction is max. Net force in x direction will be force of spring. I have minus kx on the left-hand side of this equation. On the right side of this equation, I have combined mass, m plus m, times acceleration a sub x. But a sub x is second derivative of the position. It is d2x by dt squared. I'm ready to write the equation of harmonic oscillator. Look at this. It is m plus m d2x by dt squared plus kx, and this is equal to 0. Now, if I divide both of these guys by m plus m, what will we get? We will get this iconic form of this equation. Second derivative with respect to time, d2x by dt squared, plus constant, which in this case will be k divided by m plus m times x. And this is equal to 0. Now we need to solve this equation. And we know what to do. We guess the solution as a cosine omega t plus b sine omega t, similar to what we did in the previous problem. We will find unknown constants a and b from the initial conditions, and we will find omega by bringing our guess back into the equation. So let's start with using the initial conditions. What is x at time moment 0? X at time moment 0, cosine 0 is 1, so I have a. Sine 0 is 0, no second part, and this is equal to, where is my initial condition? Here, x at time moment 0 is 0. We found a, great. In this case, a is 0. Now I need to use my second initial condition, so I need to differentiate x to find velocity. What will be velocity? Vx at any time moment as a function of x. It will be, I differentiate this guy. It will give me minus, because derivative of cosine will be minus negative sine omega t, and the chain rule will give me omega. Then I differentiate second guy. It will be plus b cosine omega t, and the chain rule omega t, and the chain rule will give me omega here. Okay, so now I use my initial condition. Vx at time moment 0. I plug in time moment 0. Sine 0 is 0. Cosine 0 is 1. So I'm left with b omega here, b omega. And at the same time, this guy is equal to minus m over m plus m. And then Vm cosine theta. We found a and we almost found b. So if we knew omega, we would know what b is, because b from this equation is minus m divided by m plus m. And then Vm cosine theta, Vm cosine theta divided by omega. All we need to do, we need to find omega. And you know what? We solved the previous problem. We already discussed it. We know what omega squared will be. It will be this guy. This will be omega squared. But let's derive it. Let's prove it one more time. So what will I do now? I will find omega. My equation, my solution for the equation now looks as x as a function of time. A is 0. It is b that we already found, almost b sine omega t. I need to bring this x into my equation. What will be the first derivative? The first derivative dx dt will be b omega cosine omega t. What will be the second derivative? d2x by dt squared. The second derivative will be, I differentiate this and I will get minus b. Then derivative of cosine is minus, I already put minus here, sine omega t, and here will be omega and another omega from chain rule, omega squared. This is my second derivative, and now I bring it back here, and the equation will be minus b omega squared sine omega t plus this guy, k, over m plus m, and then x, which is b sine omega t. I will put b here to save space. B sine omega t. Let's see if you can see it. Yes, I think you can see it. B sine omega t. And this is equal to 0. So sine omega t gone. B and b gone. And what we have is omega squared. Omega squared comes to another side of the equation. and it is equal, as expected, to k over m plus m. We found omega. Now we know everything, and we are ready to write our final solution. X at any time moment will be, I'm looking here, b is minus m over m plus m. And then Vm cosine theta divided by omega. Omega is square root of k over square root of m plus m. This is omega, and now I'm ready to write sine omega t, where omega, one more time, is square root of k over m plus m. I did not plug in omega here because I ran out of space, but it's not important. We found, I can actually simplify it, m plus m, then m plus m here is square root. And you know what? Let's still rewrite it. I will erase conservation of linear momentum, and we will rewrite it in the final form when we plug in everything in our final solution. So I keep going. X is a function of time. We just simplify this formula. Minus m divided by square root of k times m plus m. And then it is Vm cosine theta. And then it is sine omega is square root of k over m plus m, k over m plus m, and times time. Now we know x at any time moment. It is expressed in terms of what was given. We found position at any time moment, which is quite remarkable.